Okay, now on to atmosphere number 2. Write in your notes that Earth's second or evolutionary atmosphere happened 4.0 to 3.3 billion years ago and came from Earth itself because there were lots of volcanoes, many more than today, because the Earth's crust was still forming. These volcanoes released 3 things we want you to get in your notes. First was steam or water in its vaporized form of H2O. The second was carbon dioxide, CO2. And the third was ammonia, NH3. And you see these 3 components now in this diagram. So melted rock now from volcanoes produce these 3 main things. You could add methane to your list, CH4 if you would. That also in small amounts comes out of the rocks. Later on, when animals are formed, methane becomes a big issue like it is right now. But in this atmosphere this long ago, not as much. Okay, now on to atmosphere number 3, called the living atmosphere, which occurred 3.3 billion to 500 million years ago, and eventually led to our current atmosphere that we now call the modern atmosphere. So make sure you get those numbers down. Also write in your notes that much of the carbon dioxide released through the melting of rocks has dissolved into the oceans. Remember, oceans are referred to as carbon dioxide sinks because they hold so much CO2. Also write that eventually a simple form of bacteria developed that could live on an energy from the sun and carbon dioxide, this is blue-green algae, producing oxygen as a waste product, which resulted in oxygen building up in the atmosphere while the carbon dioxide levels continue to drop. Also get in your notes that the ammonia molecules in the atmosphere were broken apart by sunlight, leaving nitrogen and hydrogen. The hydrogen, being the lightest element, rose to the top of the atmosphere, and much of it eventually drifted off into space. And as you can imagine, what was left was nitrogen, which is the main part of our atmosphere. And we'll talk about how much of it is in our atmosphere shortly. Duh. Yes, get in your notes that gravity is what holds our atmosphere in place. And we'll talk in greater detail about the atmosphere when we begin our astronomy unit the last 9 weeks of class. So more later. You recognize that sound? Now let's focus on the composition of our modern atmosphere. Let's review its basic composition just so you have these components back in your notes from the beginning of class. The modern atmosphere is composed of 78% nitrogen, or N2, not N, N2 as you see right here. It's N2. It's not elemental nitrogen. It's nitrogen. It's the nitrogen molecule, N2, so 78%. 21% is oxygen, or O2. Again, not elemental oxygen, but the molecule oxygen is what you breathe. 21% of it, of our atmosphere, is that oxygen. And then 0.9%, or a little less than 1%, is this element argon. And we'll talk more about argon in our astronomy section. And the rest we call trace gases. So you see the trace gases right here, which are mainly water vapor, carbon dioxide, methane that we just mentioned, and the rest in very small amounts. But those are the 4 main ones we really want you to focus on. So that's the makeup of our modern atmosphere. Now on to the idea of atmospheric pressure. It's important because it will become vital in our discussion of climate and weather. Write in your notes that pressure can be thought of as the weight of all overlying layers of the atmosphere on the surface of the Earth. Now we're going to call it a dog pile in a later podcast, and you see a picture of a dog pile right here. We're going to look at the layers of the atmosphere here fairly shortly. But this atmospheric pressure now mounts one layer on the other. We call that a dog pile, And the force that causes it, yes, gravity. Also write that the average atmospheric pressure at sea level on Earth is measured using an aneroid barometer. You see this here, it's also called an altimeter, by the way, and is expressed in 3 different ways. At sea level, pressure is 29.92 inches of mercury, or 76 centimeters of mercury, or 1,013 millibars. All of these are equal measurements and all represent the pressure of the atmosphere at sea level, so make sure you get those down. Now let's take what we already know about the atmosphere and what we've just learned and start relating it to weather and climate. For now, just write in your notes that atmospheric pressure is directly related to weather conditions in 2 ways. First, when there is low pressure, like you see here on the left, when there is low pressure, the air is less dense, meaning there's more space between the air molecules. And that's because of this low pressure. Now, this low pressure air rises, causing clouds and stormy conditions like you see here in this picture. Okay, secondly, high pressure air is more dense, which means it has less space between the air molecules, and that's because of this high pressure. Now, this high pressure air sinks, causing the fair weather that you see here on the right. We're going to talk a lot more about weather conditions, etc. But this is just an introductory lesson on atmospheric pressure. Again, let's look at the layers of the atmosphere and get them in your notes along with their locations relative to the surface of the Earth. First, write that we live in the troposphere, which is from sea level up to about 10 kilometers. Then, on top of the troposphere is the stratosphere, which is from 10 to 48 kilometers. Also write that the ozone layer is located in the stratosphere from 25 to 35 kilometers, and that the troposphere and stratosphere are separated by a thin layer called the tropopause, which you see right here. So here's our troposphere. You can see that we live in this area. Here's the tropopause. Here's the ozone layer now in the stratosphere. Okay? In fact, sometimes it's referred to as the ozonosphere because it's where the ozone layer is. Now, write that the layer on top of the stratosphere is called the mesosphere. And you see it right here, the mesosphere, and is located from 48 kilometers to about 80 kilometers. And the mesosphere and stratosphere are separated by the stratopause. Then lastly, write that the layer on top of the mesosphere is called the thermosphere, and you see it right here, and runs from 80 to 145 kilometers, and that these layers are separated by the mesopause that you see right here. And then lastly, write that anything above the thermosphere, that'd be anything above here, is considered space. And space is a vacuum, meaning there's no gases located there. So all the rest of these layers would have gases in them of varying types. Obviously, the most dense would be here in the troposphere, and the least dense would be in the thermosphere. Now let's explore what effect elevation or distance from sea level has on temperature and precipitation. Remember, we're making our way towards weather, and temperature and precipitation are certainly a part of weather. Just look outside. First, write that temperature decreases as elevation increases, and that we call this an inverse relationship. Next, write that as elevation increases, so does precipitation, and that we call this a direct relationship. So, let's make some sense out of this using the picture in this slide. Now we're going to start down here at the Pacific Ocean right at sea level. So you see right down here is where we're going to start. So Pacific Ocean at sea level. Now, write in your notes that the air is warm and full of water evaporated off the ocean, and that as it moves eastward, eastward is this way, this direction, as it moves eastward, it begins to encounter the Rocky Mountain chain. So we're going to assume these are part of the Rocky Mountains right here. So start at the Pacific, warm. It's actually not as warm as the Atlantic, but it's still warm air. Full of water because that water is evaporated into the air. It moves eastward. All right, so it moves eastward now off the Pacific Ocean. Now, as the air is forced up the mountain, you see it forced up the mountain. It can't go anywhere else because the mountain's there. It's forced up the mountain. It cools and becomes less dense. This squeezes the water out of the air like happens when you squeeze a wet sponge. So as that warm, moist air hits the mountain and goes up and increases in elevation, the temperature decreases, just like it says right here. And as it decreases, it squeezes the water out of that air. Now, also write that this water forms clouds in the air, and that this process is known as the orographic effect. You see it right here. So warm, moist air moves up the mountain, becomes cooler, squeezes it like a sponge. The water comes out of the air and forms clouds. That's called the orographic effect. Now, next, write that the air that was once very wet is now much drier, as you might expect. Here's the air now, moving this way. Much drier as it moves down the other side of the mountain into this central valley. So it's dropped off all of its precipitation, and now it's much drier now here in this valley. Now this process continues until the air actually clears the Rocky Mountains in what we call the desert southwest, which would be over here. By then the air is extremely dry, having been forced up and down the mountains so many times. No wonder it's called the desert southwest, huh? Now that we understand how our atmosphere was formed, its many functions and its structure, let's turn our attention to what happens as a result of having an atmosphere. First, let's differentiate between weather and climate. Write in your notes that weather is the condition of the atmosphere at any particular time and place, while climate is the long-term average of the weather. Also write that the most influential factor in determining weather and climate is the ocean. So you can see this dude right here says it'll probably hit 90, and he's holding up the calendar, the month of August. That'd be climate because it's August. He thinks it's going to be hot in August. Whereas this guy looking at the thermometer is actually measuring the temperature at that moment. So climate is what you expect, whereas weather is actually what you get. Big difference between the two. Okay, that's it for part 2. Take a picture of these notes and submit them to Moodle. Go ahead and grab that study guide, answer the questions, and then submit those to Moodle, and I'll see you back here in part 3 of our discussion of the atmosphere, climate, and weather.